Lesson 3 is about solving stuff with multiple angles, and again, it's just one little bit of a side push off of what we're already doing. It's not that different. So if we imagine two different equations, cos x equals -3/2 and cos 2x equals -3/2, what I can do is I can graphically solve these things out. So if I solve it out graphically, since each of these is 30, this is going to be 60, 90, 120, 150, and 210. And so there's only two solutions in there. If I look at this cos 2x, basically I've halved the period, right? So my period is now 180 instead of 360. I get two solutions. If I were to estimate that out of there, that's going to be 75. And this one's going to be 105. And then it'll have two more solutions here and here. The things that we want to notice is that when it's cos 2x, we have two solutions here, four solutions here. The values of x are 150 and 210. And right here, there's 75, 105. And then it'll be 255 and 285. That seems right to me. Now, if you look at these two solutions, they are half of those solutions in much the same way. So the general solution here is two answers which vary by 360 degrees. So both sets of answers here are my 150, 210. And they both differ by 360 degrees because cos x has a period of 360 degrees. Here, it has two sets of answers again, 75 and 105, but they separate, each of those two sets of answers separates from its next solution by 180 degrees because the graph of cos 2x has a period of 180 degrees. So here it's going to be 75 plus 180n, or 105 plus 180n. And to see if that makes sense, what I can do is I can put 75 back into here. And that's going to be the same as cos 150, which is in fact -√3/2. And here. So on this next example, I have now tan of 2x. It still wants to do it graphically, but we're going to skip that. We're just going to move straight into algebraically because it's easier. So if tan of 2x equals √3, I basically have to undo this. So I say 2x equals tan -1 of √3. Now all that tan -1 of √3 means is that I need to check on my unit circle. On my unit circle, tan is √3 here and here. It wants it in radians, so this value right here is going to be pi thirds radians and 4 pi thirds radians. But you can see that tan is periodic over just pi. So what I'm going to do is I write 2x equals pi thirds, and when I do the half of that, I get x equals pi sixths. So the general solution consists of answers which differ by pi halves radians, because the graph of tan 2x has a period of pi halves radians. And again, I can say this is pi thirds plus pi, and when I divide both sides by 2, this becomes pi sixths plus pi halves. So there's my algebraic solution. You can see the same thing right here. So this is another algebraic one to solve. All we do is we go through the same first part, well, the first part the same way we always have. So √2/2, I just look at my unit circle, and it's going to be here and there. So my solutions are going to be pi quarters and 3 pi quarters. But then if we divide those by 3, I'm only going to get some of the answers in my domain. Remember, if I were to look at sine x equals root 2 over 2, it would look like this, and there's my answers. But if I do sine of 3x, it's going to look like that. And so I'm going to get more solutions. To see that, what I do is I go, okay, I want x between 0 to 2 pi, so I want 3x from 0 to 6 pi. And now I know that it's in quadrants 1 and 2 with a reference angle of pi quarters. So I write out all of my solutions for 3x. They're going to be pi quarters and 3 pi quarters, and then 2 pi plus pi quarters and 3 pi quarters. And then one more time around, so I'm going to get 4 pi plus pi quarters and 3 pi quarters. So now my solutions are pi quarters, 3 pi quarters, 9 pi quarters, going up by 8, 11 pi quarters, another 8 is going to give me 17 pi quarters, and lastly 19 pi quarters. And then those are my 3x values. My x values are going to be all of those same values divided by 3. So I'm going to get pi twelfths, 3 pi twelfths, which is the same as pi quarters. This is going to give me 3 by 9 is 3 pi quarters, 11 pi twelfths, 17 pi twelfths, and 19 pi twelfths. And those are all of my solutions for x. Or my general solution would be pi twelfths plus, instead of 2 pi, it's going to be 2 pi thirds. And my other solution is going to be pi quarters plus 2 pi thirds. Why? Because, oh, and these are n, where n is an element of the integers, because sine 3x has a period of 2 pi thirds. Oh, look at that. Just like it says here. Now, the general technique that we want to use here is we find the domain for the multiple angle, we solve the multiple angle, and then we add the period of the trig graph to get all of the numbers that we need in that domain. So step 1, find the domain. So because I want 2x, and it wants x from 0 to 2 pi, it's the same as saying I want all of the values of 2x from 0 to 4 pi. So now I go sine -1 of -1/2. And I look for all of the places on my unit circle between 0 and 2 pi. So that's going to be 7 pi sixths and 11 pi sixths. But that only gets me up to 2 pi. I need to go all the way to 4 pi, so I need 2 more solutions. So it's going to be plus 12, so it's going to be 19 pi sixths. And then plus 12 is 23 pi sixths. Now those are all the solutions to 4 pi, and now I cut it down by 2. And what that's going to give me is x equals 7 pi twelfths, 11 pi twelfths, 19 pi twelfths, and lastly 23 pi twelfths, which is almost 2 pi. So that's what our 23 pi twelfths is equivalent to. My general solution will be 7 pi twelfths plus pi n and 11 pi twelfths plus pi n. Why? Because they differ by pi radians, because sine 2x has a period of pi radians. All right, let's beat the bell. So here we're going to use this thing. The time it takes for the Ferris wheel to do one complete rotation, I say my period equals 2 pi over b, and that's equal to 2 pi over pi twelfths, which is going to be 24, whatever that be, seconds, I think, whatever that be. Me could speak the English. And then algebraically determine the times during the first minute of the ride where the student is 7 meters above the ground. So now what I'd do is I'd write 7 equals -4 cos pi twelfths of t plus 5. And I want all of the times during the first minute. So I want all of my solutions t from 0 to 60. And on that same regard, then, I want pi twelfths t from 0 to 5 pi. How do I get that 5 pi? By going 60 times pi over 12. That's what I get that 5 pi from. 60 divided by 12 is 5, so 5 pi. And then, so those are the domain that I need to look for from 0 to 5 pi. Back to my equation. Subtract 5, so I get 2 equals -4 cosine of pi twelfths t. Divide by -4, so I get -1/2 equals cos of pi twelfths t, and then pi twelfths t is cos -1 of -1/2. Good old unit circle. Cos is -1/2 here and there. So that's going to be, what's that going to be here? 2 pi thirds and 4 pi thirds. And that said, I can now say, oh, and actually, sorry, I need to go all the way around from 5 pi. So there's going to be lots of solutions. 1, 2, I've got those done. So 2 pi thirds and 4 pi thirds. And then I need to go around another time. So there's going to be 3 pi. And I'm going to hit that one plus another 6. So it's going to be 8 pi sixths. And then 9. Come on, brain, think. Not pi 6, pi thirds. Right. And 10 pi thirds. And then one more time around to get to 5 pi. So I'm going to hit one more here on this. So plus another 6 more should give me 14 pi thirds. So there's all of my answers in radians. And now I convert those into times by multiplying all of them by 12 over pi. So 2 pi over 3 times 12 over pi. My pi's cancel. So it should be 8. So that's going to be 8 seconds. And then this is just going to be double that, so it's going to be 8 and 16 seconds. Sure, that sounds good to me. And then because my period is 24 seconds, I can just add 24 to this thing. So plus 24 is going to make this 32. Plus 24 is going to make this one 40. Plus 24 is going to be 56. And those are all of my 5 solutions inside of 1 minute. So my t equals 8, 16, 32, 40, and 56. And not my next one should be 64 because I only want my times between 0 and 60 seconds. Whew.